Hello everyone. Hi, I am Manan and today I am going to talk about consistent hashing with bounded load algorithm, which is based on the research done by Google NYC algorithms team in back in 2016. So let's get started. So as we all know, this is a typical consistent hashing architecture in which we have 0 to k minus 1 buckets, and we assign these servers to these buckets, and basically when a request comes in, it would go clockwise around this ring, and the first server which it encounters will serve the request. But the drawback of this approach is that in case any one of the server fails, let's say S1 fails here, then other servers might get overwhelmed by the number of requests in the ring, and other servers would also fail, resulting in a cascading failure. Uh, so the researchers at Google came up with this algorithm of consistent hashing with bounded load. Uh, so the idea is to define a maximum capacity for each node or each server, and basically uh, if the number of requests is greater than the maximum capacity, the request will move forward to the next bucket. So if we talk about this example, in this case 6 and 3 will go to bucket B, 5 and 1 will go to bucket C, and request number 2 will go to bucket A. Now as for request 4, when it comes to bucket B, bucket B is already full, so it would go forward in the ring and to bucket C, but bucket C is also full, so it will again go forward, and uh, bucket number A will serve that request. Talking about its implementation, Vimeo, which is a video streaming platform, was one of the first companies to implement this algorithm and integrate it with their code base. So they were using HAProxy load balancing as a load balancing software along with consistent hashing as their algorithm, and basically they were hashing each request ID, each video ID as it came from the clients, and redirecting it to the server. So if a request for the same video comes again, it will go to the same server, and so it made sense to have local caches along with the server. But what they observed was that they weren't getting enough performance out of just local caching. Only 50 to 60% of the requests were getting redirected to the same server. So in order to improve the performance, they added a global caching service, and for which they used Memcache. Let's look at the source code where they implemented this algorithm. So this is the function which would return the server which needs to serve our request. And if we look at this highlighted area, this is the place where they check whether the number of requests for a server is greater than or equal to the capacity or the bounded load defined in our algorithm. And so if the number of requests are greater than the capacity, we will go to the next node in this elastic binary tree, and we will basically continue this process until we reach the same node from where we started, and if that is the case, we would break from the loop and return null. So yeah, this is the basic algorithm. Now let's look at some of the benchmarks. So as you can see here, this green line corresponds to the local percentage of cache hits, and this yellow line corresponds to the remote, which is our Memcache percentage hit. And so basically when they post the code on 26th of October, this is the before and after comparison of the percentage cache hit of local, and as you can see here, the local cache percentage hit increase massively after implementing this algorithm, and as a result of that, they were able to reduce the bandwidth of Memcache from around 900 Mbps to 100 Mbps, which was a massive decrease of 8 times, which was awesome. So that's about it. Thank you, and let me know if you have any questions.